In this lesson video, we will introduce the angles embedded in clock hands, and then we will practice examples on finding the angles made by hour arms, minute arms, and between hour and minute arms. When a clock's hour arm or minute arm rotates, it covers some angle. Here we will learn how much angle an hour arm cover when it's cover 1 hour of the time, or how much angle a minute arm covers when it cover 1 minute. Let us see an hour arm starting from here. When it rotates all through and come back again, that is to complete a revolution, then it's complete 360 degree. We know a complete revolution is 360 degree. That means an hour arm starting from here, when it's come back again here, that is when it completes 12 hours, then it completes a complete revolution. So in 12 hours time, the hour arm, we are talking about this hour arm, in 12 hours time, an hour arm completes 360 degree. It starts from here and then here. So when it's go from here to here, that is when it completes 1 hour, or here to here, or here to here, then how much it completes? In 12 hours time, it completes 360 degree. So in 1 hour time, it will complete 360 division 12. That means 30 degree. That is why it is shown here that when an hour arm, this arm, basically it's not this one, this hour arm comes from here to here, so this 1 hour span makes 30 degree angle. Let us see how much angle a minute arm covers when it covers 1 minute. Now the question is, how many minutes are there? When this minute arm starts from here and go around and complete this round, it's complete a revolution. That is, a minute arm completes a revolution in 1 hour. In 1 hour time, a minute arm start from here, go round and come back here. So in 1 hour time, a minute arm covers 360 degrees. So in 1 hour time, the minute arm, we are talking about now, the minute arm covers 360 degree. And now in 1 hour, we know there are 5 minutes in each of this span. So there are total 60 minutes in an hour. So 60 minutes, when a minute arm covers 60, 1 minute, 2 minutes, 3 minutes, in this way 60 minutes, then it actually covers 360 degree. So for 1 minute, it will cover 360 division 60, that means 6 degree. So that is why here it is shown that when a minute arm, this is not shown for hour arm, this is shown for minute arm, that when a minute arm goes from here to here, that is covers 1 minute, or goes from here to here, it covers 6 degree. It covers the 6 degree angle. So we will use this to information that when an hour arm moves 1 hour, it actually moves 30 by angle 30 degree, and when a minute arm moves 1 minute, then it moves or covers 6 degree angle. So we will use this to information to calculate many aspects regarding angles involving clock hands. Now we will use the information that we achieved in our last slide, that is, when an hour arm moves 1 hour, it covers 30 degree, and when a minute arm moves 1 minute, it covers 6 degree, to do some example problems. Let us start with this example. Calculate how many degrees the hour arm rotates in 3 hours. So we know when an hour arm moves 1 hour, it covers 30 degree. So for 3 hours, it will cover 3 times 30 degree, that is 90 degree. Question 2. When an hour arms cover 9 degree, so for 1 hour it is 30 degree, so for 9 hours it will be 9 times 30, that is 270 degree. For 3 days, for 1 hour it is 30 degree, so we need to convert these days into hour first. So 3 days equals 3 times 24, that is 72 hours. So in 72 hours, in every hour the hour arm covers 30 degree. So in 72 hours the total angle will be 72 times 30 degree. That means if we multiply it, we will get 2160 degree. So the hour arms will cover this much degree in 3 days time. 4. In a week. So we first need to convert the week into hour. 1 week means 7 days, means 7 times 24 hours. So this many hours means 1 week. So in every hour the hour arm will cover 30 degree. So the total angle covered will be 7 times 24 times 30 degree. If we calculate it, we will get 5040 degree. So in a week time the hour arm covers this much angle. Find the angle between the initial and final position of the hour arm after these hours. In our last example, we calculated how much in total the hour arm will rotate for many different hours. But what happened actually is, say if a hour arm start from here, after 12 hours it's come back again in that position. After 12 hours it comes back again in the same position. So what happening here in this question, what we are asking is that after 5 hours of time, that is if the hours clock start from here, then 1, 2, 3, 4, 5. After 5 hours it will come here. So we are asking in this question that what will be the angle between the initial and final position when an hour clock moves 5 hours or 14 hours. So when an hour clock, say starting from here, when an hour clock will move 14 hours, so what will happen, it will go around, after 12 hours it will be again in the same position, and then 13, 14. So 14 hours, after 14 hours the hour clock will be here. So the angle between initial position and final position will be this. So in this way, in every 12 hours time, the hour clock will come back into its initial position. So to find the angle between initial and final position, first we need to convert these given hours in less than 12 hours. So that means after every 12 hours it will come back in the same position. So after that, how many hours it will be moving, that will determine the angle between its initial and final position. So let's do one by one. So for first problem it is 5 hours. So 5 hours it is not rotating. So 5 hours angle will be easy. For each hour, hour clock make 30 degree. So for 5 hours it will be 5 times 30, that is 150 degree. So this will be the angle between its initial, that is this is the angle from here to here, 5 hours, this will be the angle. So that angle is 150 degrees. So after 5 hours the angle between its initial and final position will be 150 degree. For second case, for 14 hours is greater than 12 hours. So what we will do, we will convert it into, we will subtract 12 from here, so we will get 2 hours. So for 14 hours, after 12 hours the hour clock will be in the same position, and then these 2 hours will move. So we just need to calculate the angle for 2 hours. So in every hour the hour clock moves 30 degree. So for 2 hours it will be 2 times 30, that is 60 degree. So when a hour clock will move 14 hours, say starting from here, it will move 12 hours first and then 1, 2. So the angle between its initial and final position will be 60 degree. Question 3. 4 days and 21 hours. So first we will convert it into hours. 4 days and 21 hours equals 4 times 24 plus 21 hours. So it will be, so we don't need to actually do that, because 4 days. 4 days means in every day 2 times it will rotate and rotate. So 4 days means 1 rotation, 2 rotation is 1 day. This way 4 days will cover. So after 4 days, complete 4 days, the hour clock will be in the same position. Then this 21 hours. And among these 21 hours, so for days we don't need to calculate anything. Complete days, hour clock will always come back in the same position. We just need to concentrate on the hours part. Now 21 hours. After 12 hours, the hours clock will come back again in the same position. So we need to 21 minus 12. That is 9 hours. So we just need to calculate the angle for 9 hours. So 9 hours, in each hour the hour clock covered 30 degree. So the angle will be 9 times 30. That means 270 degrees. So the angle between initial position and final position of the hour clock after 4 days and 21 hours, it will be 270 degree, because 4 days of movement will bring the hour clock in the same position, and then another 12 hours will bring the hour clock in the same position. So only the next 9 hours. So from here 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be the final position. So this is the angle between initial and final position of the clock, and this is a reflex angle. Definitely this is a reflex angle. And if we want to calculate the other angle between this our initial and, then we need to subtract from 360 degree. So 360 minus 270, sorry, 9 times 30, 270. So basically from here 9 hours, 1, 2, 3, 4, 5, 6, 7, 8, 9. It will come here, not here, here. So this is 270 and this angle will be 90 degree. So either we can say that initial and final position, the angle is reflex 270 degree, or we can say that the angle is right angle, that is initial position and final position angle will be 90 degree. So in total, in summary, if the angle is less than 12 hours, we will just multiply 30 degree, we will get the angle between initial and final position. If the angle is greater than 12 hours, then we will subtract 12 hours from there, and the hours we will get, we will multiply that hour with 30 degree, and then we will get the angle between initial and final position. And if we have days and hours, we will just discard the days, because we know after complete 1 day, the hour clock will come back in the same position. We will just concentrate on the hour part, and if that hour part is greater than 12, we will subtract the 12 hours, because after 12 hours, hour clock will come back in the same position, and then the rest of the hours we will multiply by 30 degree and get the angle. And if it is greater than 180 degree, then it is a reflex angle. And if we want to calculate the acute angle or right angle between them, then we need to subtract this reflex angle from 360 degree, then we will get the acute angle or right angle between the initial position and final position of the our arm.